Hi, I'm Mudinda and I'm here to help you understand maths better for free. Today, we're looking at a past exam example on grade 12 analytical geometry. Now, before we jump right into it, just a couple of things to note. Firstly, I do suggest that before watching this video, you've watched every single one of the three-part video series we've done on grade 12 analytical geometry, or at least you understand grade 12 analytical geometry. Secondly, since maths builds on and on, it's important that you understand grade 11 analytical geometry as well, so I do suggest that you watch the video that we have up on that. And lastly, you learn maths by doing it, so because we're doing a past paper today, I do suggest that you try the questions first before just watching us do it. Or maybe pause with each question, try it first, and then check if we get to the same answer or what mistakes you've made. Let's get into it. We're told here that in the diagram, there's a circle with center O. That's this small circle here, and it has the equation x squared plus y squared is equal to 20. That's because it has a center at the origin. Then we're told there's another circle with the center coordinates point G with coordinates t is to 0, this larger circle here. We're also told that there's a tangent that runs through the points D, E, and F. That's this one. And additionally, that point D has the coordinates p is to negative 2. This point here has the coordinates p and negative 2. In 4.1, we're given that if d is p is to negative 2, then show that p is 4. Okay. Well, you can see that d is on the smaller circle. The smaller circle has equation x squared plus y squared is equal to 20. Now, if d has the coordinates p is to negative 2, we can substitute y value of minus 2 to find the corresponding x value. Remember, in this equation, if you plug in a value for y, the only unknown will be x, and so we can solve for it. In fact, let's replace x with p. So we have p squared plus negative 2 squared is equal to 20, meaning p squared plus 4 is equal to 20, meaning that p squared is equal to 20 minus 4, which is 16. So p can either be plus or minus the square root of 16. But because we can see that D is in the fourth quadrant, that means it must have a positive x value. And so therefore P is positive square root of 16, which is 4. Great. Let's look at the second one. Now, in 4.2, we're told that E is the midpoint of DF. So this point here, E, is right in the middle of the points D and F. We're also given the coordinates of point E, 6 is to 2. Then we're asked to determine the coordinates of F. Now, we found in the previous question that the x value of D, P, is 4. So we have the coordinates of D. It's 4 and minus 2. The midpoint, E, we have the coordinates of that now, 6 is to 2. What we don't have is the coordinates of F. But we know from grade 11 maths, or grade 11 analytical geometry, that if E is the midpoint of D and F, then the coordinates of E, the x value can be found by taking the x value of D plus the x value of F, all divided by 2. On the other hand, the y value of E can be found by taking the y value of D plus the y value of F over 2. But we already know the x value of E. It's 6. That means the x value of D plus the x value of F, all divided by 2, is equal to 6. The x value of D is 4. So 4 plus the x value of F over 2 is equal to 6. Now, if I cross multiply here, I'll get that x value of f plus 4 is equal to 2 times 6, which is 12. And so that means that therefore the x value of f is 12 minus 4, which is 8. Now I'm going to perform the same thing with the y value of d. We know y value of d plus the y value of f, all divided by 2, must be equal to the actual y value of E that we already know, that's 2. Now the y value of D is minus 2. So we have here minus 2 plus the y value of f over 2 is equal to 2. Now if I cross multiply here, we'd get that the y value of f minus 2 is equal to 2 times 2, which is 4, meaning the y value of f is 4 plus 2, which is 6. And so f has the coordinates x value of 8 and y value of 6. And if you look at f, it does make sense that it has a positive x value and a positive y value. Great, let's look at 4.3. Great, now in 4.3, the question is to determine the equation of the common tangent, df. This is df over here. Now, if we want to find the equation of that, it's actually very easy because we have more than 1 point. We have 3 points, in fact. I'm going to just use 2 points to find m by taking the y value of the 1 point minus the y value of the other, all divided by the x value of the 1 point minus the x value of the other. I'll go with point D, which has coordinates 4 is to -2, and point F with the coordinates 8 is to 6. We found these in previous questions. That means that the gradient of df would just be the y value of f minus the y value of d, all divided by the x value of f minus the x value of d. So we have here 6 minus -2, all divided by 8. Yeah, 6 minus -2 divided by 8 minus 4. So 6 minus -2 is 6 plus 2, which is 8. So we have here 8 over 4, and we get 2. So in terms of y is equal to mx plus c, since we found an m of 2, that means this is y is equal to 2x plus c. And I'll go ahead and substitute one of the points. I'll go with f, 8 is to 6. In place of y, put 6. In place of x, put 8, in order to find what the value of c is. So we have now c is just 6 minus 16, which means that c is -10. So that equation of the tangent df is y is equal to 2x minus 10. Great. Let's look at 4.4. Now, in 4.4, we're being asked to determine the value of t. So t is the x value of the center of this circle. Now, in a previous video, we talked about tangents to a circle. And one of the most important things we talked about is that a radius and a tangent are always perpendicular to each other, at least at the point of contact. If you have a radius, such as this one, and a tangent, and they meet at the point of contact, that means that that radius is perpendicular to that tangent. Now, what do we know about perpendicular lines? It's that the product of their gradients is -1. So since we know the gradient of the tangent, and the gradient of the tangent we found to be 2, right? M is 2. Then I'll write here 4.4. Then the gradient of the tangent multiplied by, or maybe let me even start by saying df is perpendicular to fg. Why? Radius is always perpendicular to the tangent. So therefore, the gradient of df multiplied by the gradient of fg would be equal to -1. So 2 times the gradient of fg is equal to -1. Dividing both sides by 2, I'd get that therefore the gradient of fg is -1/2. Great. We now have the gradient of this line. We can even find the equation of this line now by substituting the point f in order to find c in y is equal to mx plus c. The same thing we did in the previous question for the tangent. So I'm going to say here, well, y is equal to mx plus c. So y is equal to -1/2 x plus c. This is the equation of the radius, fg. Then I'm going to go ahead and substitute point f with the coordinates 8 is to 6. So in place of y, put 6. In place of x, put 8. 6 is equal to -1/2 times 8 is -4. And so c should be equal to 6 plus 4, which is +10. So therefore, y is equal to -1/2 x plus 10. Okay, this is the equation of our radius. Now that we have the equation of the radius, we can replace y with 0 to find what the corresponding x value is. Remember, we have a point G on that radius, t is to 0. So let me go ahead and substitute that point into this equation. That's going to help me solve for x, because if I substitute a y value, the only thing that will be unknown there is the x value. So I'm going to say here, well, 0 in place of y is equal to -1/2t plus 10. So I've replaced x with t and y with 0. Now, -10 is equal to -1/2t. Multiplying both sides by 2 is going to give me -20 is equal to -t. And therefore, dividing both sides by -1, t is equal to +20. I just want to say as well, there is other ways that you could have answered this question, and that's completely fine. But this is how one of the ways that you can tackle it, right? We know that the gradient of this line, we don't know it, but we do know the gradient of the tangent. And we know that a tangent is always perpendicular to a radius. The gradient of the radius is times the gradient of the tangent is therefore -1. So we can find the gradient of this radius. Once we found it, we can substitute the point F to find the full equation of that radius. And we can substitute a y value of 0 to find what is the corresponding x value. In other words, t. Great, 4.5. So 4.5 says to determine the equation of the largest circle in the form ax squared plus by squared plus cx plus dy plus e is equal to 0. Now, I know you've probably never seen that before. That just means expand the normal form or the form that we're used to of the equation to that circle. So what do we need in order to have the equation of a circle? If that circle's center is not at the origin, we need the center of the circle, right? And we also need the length of its radius. Okay, so we have the center of the circle. We now know that g is 20:0, right? But we also need to know how long this radius is. Remember, the equation of a circle is x minus a squared plus y minus b squared is equal to r squared, where a and b are the x and y values of the center, respectively, and r is the radius. Okay, so that said, let's find r. We know that g is just 20:0, but let's find the radius, the length of fg. F has the coordinates 8:6, g has the coordinates 20:0. So how long is r? Is the square root of y value of f minus y value of g all squared plus x value of f minus x value of g all squared. Great. So the radius r, so f 8:6, g 20:0. I'm just writing these here so that I can see them. R is going to be y value of g, which is 0, minus y value of f, which is 6 all squared, plus 20 minus 8 all squared. Okay, this is the radius. Okay, so r is going to be, and in fact, we can find r squared. We don't actually have to find the radius. We just have to find r squared because the equation only has r squared. Okay, so let's take away the square root sign and just find r squared. R squared is 36 plus, now 20 minus 8, that's 12, and 12 squared is 144. Okay, now 144 plus 36, that's 180. So r squared is 180. So this means to us that this equation, we no longer have to say x minus a all squared plus y minus b all squared is equal to r squared. We can replace a with the x value of the center, that's 20. We can replace b with the y value of the center, which is 0, and we can replace r squared with 180. Okay, so the equation of this circle is, oh, sorry, 1 second. Sorry, all my iPad's pen had died there. So this is now x minus 20 all squared plus y minus 0 all squared is equal to r squared. So more formally here, we have x minus 20 squared plus y squared is equal to r squared. Now, we just need to expand, move everything to one side, leave 0 on the other, and we'll have this form. So this will be x squared minus 40x, and then that's 20 times 20. That should be 400, yes. Plus 400 plus y squared. Right. Instead of r squared here, I should have replaced that with 180. Okay, 180, 180, 180. And let's go ahead and move the 180 to the other side. Minus 180 is equal to 0. Okay, great. Now, 400 minus 180 leaves us with 220. So we have here x squared plus, let's go with y squared. Then let's go with minus 40x and then plus 220 is equal to 0. So that's because they started with the x squared term, then the y squared term, then the x term, then the y term, which we don't have because that was just 0 over there, and the constant term 220. So this is the equation of that larger circle in that form. Great, let's look at 4.6. Great, so matriculants, 4.6 is a bit of a tricky one. It says the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Okay, now what does it mean to touch a circle internally? Well, to touch externally means something like this. This is two circles that are externally touching each other. When we say two circles touch each other internally, we mean the other circle is inside of the other one, but it touches it just at one point. So what we need is for the small circle to move along the x-axis. So shift this circle to the right up until it looks something like this, right? Or another option is for it to touch it on this side here. So maybe we could also move it all the way until it touches the bigger circle somewhere here. But the bottom line is, how much should we move this small circle to the right in order for it to internally touch the big circle? That's what this is asking you. How much should you move this small circle to the right for it to either look like this or look like this? That's all you're being asked there. Okay, the smaller circle, it says there, the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. So calculate how much we should move it along the x-axis for it to touch the bigger circle internally. Now, if we want to find out how much a point should move to the left or the right, I'll give you a very basic example. Imagine that you had a blue point here, and you had, let's say this was a blue point here, and you had a red point there. And let's say the x value here was 2, and the x value there was 7. And I asked you, how many times must this blue point move in order for it to reach the red point? You'd obviously scream, well, 5 times, right? Because you can see visually and you know the distance between 2 and 5. But the formal way to do it is to take the x value here, the 7, and subtract the x value here, the 2. Now the reason that works is because when we say that the x value here is 7, we mean that the distance from here to there is 7 units long. When we say the x value here is 2, we mean that the distance from here to there is 2. And so taking the red arrow and subtracting the blue little arrow, right, leaves you with the distance between them, which is how much this blue point needs to move in order for it to reach the red point. So that said, to answer this question, I'm simply going to find, well, what's the x value here? And what's the x value here? Because I just need to move this point all the way to here for us to get that diagram that looks like this. Okay, that's all I need to do. And how can I find that? By just taking the x value here minus the x value there, much like we just discussed there. Or, on the other hand, I need to figure out what is this x value and what is that x value. Because if I can move this point all the way here, then I will have the diagram that looks like that. So the journey ahead of us is to find out what are the x values here, 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 and there. Okay, what are the x values there? That's what we need to find out. Let's start with the smaller circle. How can we do it? Well, what's the radius of the smaller circle? The radius, or r squared, is 20, right? So if r squared is 20, that means r is plus or minus the square root of 20, meaning r is either negative 2 root 5 or r is positive 2 root 5. So that's the radius. So the distance from 0 to there is negative 2 root 5. The x value here is negative 2 root 5, while the x value here is positive 2 root 5. What about on the bigger circle? Well, on the bigger circle, now for these points here, on the bigger circle, we know that the radius of the bigger circle, if I can just check on our previous, we found it to be 180. So r squared is 180, meaning that the radius r is plus or minus the square root of 180. Now the square root of 180 is 6 root 5. So the radius is either negative 6 root 5 or the radius is positive 6 root 5. Okay. Now, note that this circle doesn't start at the origin. So it's not as easy as us saying, oh, this is 6 root 5, or this is negative 6 root 5, that's 6 root 5. It wouldn't even make sense now, would it? Because at this point here, this is a positive x value, it's not a negative x value. Instead, we need to think about this in relation to the x-coordinate of the center. So the x-coordinate of the center is 20, right? And the distance here, how long is this? It's 6 root 5, because that's the radius of this circle. So that point here is 20 minus 6 root 5, while this point here is from 20, we add the radius. So remember the x value here is 20. So this one is 20 plus 6 root 5. This doesn't really simplify. If you put it in a calculator, it should stay like that, okay? But you can also turn it into a decimal. Great, we now have the 4 points. So now the first case is if we moved this to the right so much so that it came and touched like that, okay? So that's the first option we have. It's to move this small circle to the right so much so that it gets into the circle, and then the point that it's touching is the other circle is there. How can we figure that out? Well, we'd like this point to come and touch, so this point to come and touch that point. So we just need to take the x value here minus the x value there. So k for the first case is 20 plus 6 root 5 minus 2 root 5. So that is 20 plus 4 root 5. I'll check what it is as a decimal in just a second. The other option that we have is to move it only up until it now looks like this. Okay, that's the other option. Okay, that doesn't look very accurate. So that's going to require that this point come and touch here. Okay, which means we need to take the x value there minus the x value there. And that is now that k is 20 minus 6 root 5 minus negative 2 root 5. So k is 20 minus 8 root 5. Let's find these as decimals. We had 20 plus 4 root 5 up there. That's about 28,94. On the other hand, we're 20 minus 8 root 5. And that was 2,11. Okay. 20 minus 6. Oh, wait a second. I may have made a mistake. This should be not 8, but negative. So 4. Yeah, this should have been negative 6 plus 2, which is negative 4. So negative 4 root 5. Okay, and according to my calculator, 20 minus 4 root 5, that actually gives me 11,06. Okay, so this is how much you would have to move one of these two, either one, right? It's either you are moving this circle up until this point now comes here and we have this situation, or you're moving it up until this point comes here and you have this situation. Now, if this confused you a bit, rewatch it maybe a couple more times, right? Rewatch it a couple more times, try to make sense of it, because this idea of internal and external touching is a common thing that they ask you. Thanks for watching this video and see you.